Okay, now that we've taken a look at the keyboard, let's go ahead and shift our focus on over here to the mouse. So first things first, let me go ahead and come over here and create a new layer real quick. And we'll hide this one out. We'll do just like we did with the keyboard. Let's start out by writing down mouse dot get state. And mouse.getState is going to return to us a mouse state. And inside the mouse state struct, let's take a look at the members that we have. Starting out, X, Y. So basically X, of course, being our horizontal position of the mouse, Y being the vertical position of the mouse. Then we have left button, right button, and then for more modern mice, we have X button 1, and of course X button 2. Now, as all of these guys are buttons, they are going to be returning back to us a button state. And that's just another enumeration that just basically contains pressed and released. So we can tell if the button's down or not. And in X and Y, this is going to be an integer value, as we've already talked about in the very first video in the input section here, where this is going to represent a location on our screen where the mouse cursor is currently at. And so from all of this information right here, we can put together a very simple application that will do the following. So upper left-hand corner of our screen, Logan's going to have a couple braces. We'll have X, colon, and then some number that will represent where we are horizontally on the screen. And then Y, colon, and again some number to represent where we are on the screen. And then we'll end off the brace. And then we will have another one of those button frames that you saw in the last video. A little bit wider though this time. It's going to have left button, and another one. Ooh, lovely lines, lovely lines. That is going to have the right button. And then finally, we will have a little cursor that will move around. So basically when Logan's moving around the mouse, we're going to have our own sprite for our own cursor as opposed to using the Windows cursor. And Logan's going to talk about why it's a bad idea to use the Windows cursor, because you can run into some sync issues. And then of course when we press the left and the right button, the idea is to have these buttons shade just to indicate that that button is currently being pressed in. And then we want to see these numbers update as the mouse is moving around the screen. So that's the whole idea of the application. Again, very simple application, but at least with this video here, you'll understand how you can get basic mouse support into your own games. So Logan, with that, let's go ahead and shift our attention over to Visual Studio.
Okay. I'm going to bring up a fresh Visual Studio so that I can start a new project for the mouse example. For this project, I'm going to call it mouse input.
Okay.
Or excuse me, input mouse. And we'll use that for our project name. And inside of this project, the basic setup is going to be very similar to the keyboard input. I'm going to need a sprite batch and need to initialize it. And I'm going to get some of the other things too. I want to keep those colors, and I'll keep the same general look and feel of the old app.
Okay.
That means just to speed the framework a little bit, I could actually copy some of the values from the old project. This is the keyboard input project we had done in the last lesson. And
which this means, if you did not watch the last video, it's going to make this video a little bit more difficult to understand. I just wanted to throw that out.
Right, because there's going to be a bunch of magical fields and values then. But the core of the input stuff should still work.
Yeah.
But what I want to do is, I'll copy all of these and just delete what I don't need, and then maybe add a few. What I'm copying is the sprite batch field, the sprite font field, the 2 texture fields, and the fore and back color. I'm going to copy all of those fields and paste them into the new input mouse project. So our sprite batch, a font, and the button and fill. Now this project does not yet have a textures folder or any of the related assets, so I need to set that up now here under the project. So I'll make a new folder. I'll call it textures, just like we have been doing in any of the sprite batch based lessons. And now I need the actual asset files to be placed in the project directory. I have such asset files in our working directory. I have 3 PNG files, and I've also got a sprite font file. You'll notice that if you create a sprite font asset inside of Visual Studio and store it in whatever folder, if you actually go and look in that folder, you should see that file name as the asset. And if you wish, you can copy that between projects so you don't have to keep recreating it. And that's what I've done right here. I've got 3 new images, but I have the old sprite font, the Tahoma sprite font from the last lesson. I'm going to copy all of these now, and then I'm going to bring up my projects directory. And here we have the newly created input mouse folder. Then inside of that we have our textures folder, where I'm going to dump all of the assets, including the sprite font. Then I can add them inside of Visual Studio. We'll go to add existing item. We'll pull in textures, switch to content pipeline files, and you can see that the sprite font is listed under the content pipeline files. So I'm going to grab all of those, add them in, and now I have the actual assets added to the project. So looking at these, we're also going to need some different fields, because now we have additional things. We have a cursor, and I also have the button called wide button, since we need more room to write the text for L button and right button when we do the mouse, actual mouse buttons. I guess one final point of interest is if we want, we can open up the sprite font, and we still have the ability to edit it to our heart's content. It's still the same XML file that it was before. That's all we really copied. But let me adjust some of these fields. Button, I'm just going to leave it called button. Fill can still be called fill. So I'm now going to, add in a field that I can call cursor. And let's see, is there anything else we need right off the bat?
I don't think so.
Because I think that fits everything. We just have the addition of a cursor.
Okay.
So let's jump down. We need to
initialize. Go ahead and get the sprite batch going.
Yeah, I was just about to jump past that straight to the content loading. But yes, it would certainly be a good idea to create the sprite batch. So sprite batch equals new sprite batch, given the graphics device. Alright. And now the load graphics content. Since the other project is just sitting there open, it's very tempting to go in there and just snag these lines and add the additional cursor line. So all I'm doing is jumping into the last project, or if you wanted, you could even type these out. These are standard content.load for the type given the asset. But for brevity's sake, I'll copy all of those and I'll paste them into the load graphics content, load all content section. So the font is still called Tahoma. Button is now called wide button, so we want to account for that. So wide underscore button. Fill is still called fill, but we have the addition of the cursor asset. So I'm going to say cursor equals content.load textures, and then the name of the asset, just cursor. And that should have all of the assets loaded in now.
Okay.
And I believe now we can take a look at handling some actual mouse input. So I'm going to jump down to draw. And I guess as a side note with this input handling, up until now we've been handling all of the input inside of draw. This just crossed my mind, because generally when you have real game mechanics taking place in Update, that's generally the preferable place to put input handling.
Yeah, that's why I was saying in the last video, the idea of these little simple applications is just to get straight to the point and demonstrate a technique, not an overall programming style.
Purely visual, not highly interactive.
Right.
It's all been done from draw.
Yeah, so guys, please keep that in mind.
Though we did show setting the state all the way back in initialize, when we were initializing the last keyboard state. So at least that demonstrated that it really doesn't matter where you are or what time it is. You can pull for input pretty much whenever you feel like.
That's right.
It just usually goes hand in hand with game mechanics from Update. But in our case, we have no game mechanics, so I'm going to jump directly to draw. And we can do basic stuff like setting up the sprite batch begin and end, just to get that out of the way and get the sprite batch ready. So we'll do a call to sprite batch.begin, a call to sprite batch.end, and now we're ready to draw anything that might be relevant to us. And the first thing out of all of the mouse input that I want to take a look at is the mouse position. How can we do something useful with mouse position? And for that we have to begin with the state. I'm going to make a mouse state variable to hold the mouse state, and I'll simply call it mouse state. And now I wish to pull the mouse input from the mouse, so we'll use the mouse class's getState function, and that will store the state of the mouse in our mouse state variable. Now, if we take a look at that mouse state variable, we can see it offers many of the things that you've drawn on the whiteboard. We have right button, left button, we have an X, we have a Y, so we have coordinates. So,
I don't think I ever even mentioned, by the way, what the X button 1 and X button 2, that's your forward and back buttons, by the way, on more modern mice that are designed to work with browsers. And, of course, there's a scroll wheel value as well. Like I said in the last video, I was just going to kind of hit on the big things you're going to use most often.
Right. But, I mean, we can see all those things and more now. So we have the X and the Y, both given, as we can see by the tooltips, as integers. Now, we had talked about taking these X and Y values and packaging them into a vector2 so that it would be more convenient for use of draw routines. So let me actually set up that line of code, that same line of code that you had drawn on the whiteboard as an example.
Okay.
So what I want to do is I want to make a vector2 which we can call mouse position. And we can set that equal to a new vector2 where the X component is mousestate.x and the Y component is mousestate.y. So this will package the two integers into a vector2 for us.
Okay.
Now with that vector2, we can use that, or we can display that out. Before I even go to use it to position anything, I'm just going to use the vector2's toString just to dump the values, so we can get a textual representation of what they're doing. So I'm going to begin everything with a call to draw string. So we'll draw out, we have the same font asset loaded, so I'll use font. And for the text, I'll just dump out mouse position dot toString, and I'll let it worry about whatever formatting it needs to do. For the position, temporarily we could do maybe another 10 by 10 offset.
Okay.
So vector2 10 by 10, and then the color, we have stolen that 4-color value from the last project, the keyboard input, so I have that available. And I think that's everything. We've got just a very simple input state being stored, a position vector being created from that, and then we're just displaying that input vector to the screen. I'll, of course, build really quick and make sure that I haven't introduced any errors, but the build succeeded, so now we can run. And there we go, though that color does really not look that great on blue, so
no.
we take just a moment and change that to black. There we go.
Very nice.
So now, as we move the mouse around, we can see those values update. Now, on our end here, we have the mouse disappearing as it appears over the screen, and that is simply the default behavior of an XNA game, and that is to hide the Windows mouse cursor. To help with seeing where these values are landing with the mouse, and before we get into custom cursor drawing, let me take just a second and enable the Windows mouse cursor for the game, so that I don't have to necessarily worry about drawing my own. I could go all the way back up either to the constructor or initialize. Since it's a game property, it shouldn't matter in either case. I'm going to dump this into the constructor, though. I'm going to set this game, one of the properties of the game class is the isMouseVisible property, which, being a game class, I could access using this dot isMouseVisible, and I could set that property to true. And if I do that and run, now the mouse cursor isn't hidden when you move it over your game. So with this now, I can point out exactly how these coordinates are working. I mean, we can see obviously that there are numbers, and they seem to get larger as we go to the far ends of the screen. But if we look really closely, we can see that the 0, 0 position is interesting. Instead of default Windows behavior of having 0, 0 being placed at the top left of the screen, instead, it's performing the offset for us already, so that 0, 0 resides right at the very top left of the drawable area inside of the game. So that means the mouse input has already been translated to be relevant to screen space inside of your game. So that's very convenient, so no further calculations are necessary. So we can see that this space is always relevant to this game window only. And while it still works outside of it, so I mean one could still pick up values and technically move something off screen if there was enough screen space to do that. And you need to keep that in mind. So it does take into account the entire monitor size when using the mouse. But that was just really quick to point out, one, how the coordinates are working, and also that if you wish, you can set up a visible cursor of your own.
But now, there is a problem with having the Windows cursor.
Well, if you draw the Windows cursor and your own cursor, you'll actually notice a different leg offset. Or if the cursor is used for something that you can see visually while dragging,
right,
and that is the game is set to run at a specific update interval. That is, if you're doing all the update code inside of update. Or if you're doing inside of draw, that may be limited by your refresh rate. And both of these values can be different than the actual speed and refresh of the mouse itself in Windows. In some cases, with certain drivers, the mouse refresh itself might be significantly faster than your frame rate or your update interval. And what that would be shown as, or what it would look like, is that the physical Windows mouse cursor is getting it or would get ahead of your own. And that's just that Windows happens to draw the cursor before your input polling occurs, and therefore your game cursor is drawn a little bit behind.
Right.
So, I mean, in some cases, the result can look undesirable if you have both the Windows cursor and your own. Generally, if your game is going to have a mouse cursor and that cursor is going to be interactive, it's generally a good idea to just go ahead and make an in-game cursor for your mouse input.
Exactly.
But, I mean, it is useful to turn the mouse on if you just need to debug something with the mouse. Maybe you're not going to have a visible cursor at all and you just want to see where the mouse is at. So, I mean, that can be useful. I'm actually going to leave it on for a minute, too, because I want to see if any of those offsets will actually pick up on the recording.
Okay.
But now, before we get to that, let's see. Actually, we could go straight into that now.
And draw the cursor.
We've got a position. We've already verified that it is accurately in screen space.
And we've got a texture 2D representing our cursor, so let's just use it.
All right. Let me jump in right before the drawstring so that any text would be drawn over the cursor. Let me set up... You know what? I changed my mind on the fly. I'm going to draw it afterwards.
Okay.
I'm going to draw out that, like you're saying, the cursor graphic. So I'm going to do a sprite batch draw call. And I'm going to draw using the cursor field. And the position we have already figured out and stored in mouse position. So simply plug in mouse position. And then the color, I'm going to give it...
4-color.
4-color, since I designed the cursor as a kind of black and white, so the darker shade is actually part of the cursor, not part of the coloring. So I'll color it with 4-color, and then run. And now we can see behind the Windows mouse cursor, we can see the custom cursor. And as I move the mouse around, depending on how well the recording picks up, you may be able to see frames where the Windows cursor and the drawn game cursor are in different locations.
Right. So if you were actually, as Logan said a few minutes ago, dragging something around, so the game is, of course, relying on your mouse's position, but you've got the cursor from Windows visible, you're going to feel like there's this a
it
little
feels like
laggy.
there's this loose play between the Windows mouse and any of your game items.
Yep, exactly.
That you can actually get the opposite effect going if you turn off the standard interval and let the interval run at full speed and then turn off VSync. You can get into a scenario where the game will run faster than the Windows mouse update. And you can, if you try, you can get the mouse, the in-game cursor, to get ahead of the Windows cursor just by a little bit. But if accurate dragging like this is desirable, then it would be best just to go with an in-game cursor only. And that means now that we have one, I'm simply going to turn off the display of the mouse cursor for the game. So I'll simply remove that is mouse visible line. And now we're left only with the in-game cursor. And that little bit of lag is unintelligible as long as you don't physically have the Windows cursor laying directly over it.
Exactly.
Because now we're simply updating at the game's update interval, which is 60 frames a second. So now we have a custom cursor being drawn at its proper graphics, and theoretically off-screen. You can see, if I move the mouse very close, you can just start to see the edge of that cursor graphic, even though the cursor is actually off-screen right now. And you can see the negative value for X. So, I mean, it's still taking into account negative values, but now that the Windows cursor hides over the game, we're left with only our in-game cursor.
Okay.
So, really,
ready to start building up the buttons now?
Yeah, I think now would be a good idea to go and throw the button display in.
Okay.
We already have a function that's very good for drawing button state. We had made that back in the keyboard input lesson. So I'm going to steal that method just to get a head start on some of the coding, since the idea was to have a draw key method, then that layered display that you had drawn out. So what I'm going to do is steal the entire draw key method from the keyboard input lesson, and I'm going to paste that into the mouse input project. Now, I do want to make some changes. I want to adapt this somewhat so that it works better with buttons, works more directly with buttons, and then change the naming a little bit to represent the fact that it deals with buttons. So the changes will be a few, and they are as follows. Draw key is going to be changed to draw button for the name of the method. And the method is going to take in a button state instead of a boolean. And before I plug that in, let me demonstrate where I'm getting that value from. Let me go back to the mouse state for a second, and let's take a look inside our mouse state and look at exactly what the left button and right button, all of the buttons are. If we look at the tooltip, they are of type button state. So in order to make this method more direct, I want to be able to feed a button state directly over to it. I mean, if we wanted, we could also do an if statement, like if button state is pressed. Do you want to maybe look at it?
No, just feed it over directly.
Okay. So that's where I'm getting button state from. I want to feed a button state value over to draw button. And I'm going to call that just button state. And then I'll use that internally, so the check is actually going to need to be processed inside of draw button. That means we no longer have a pressed value to know if we should draw the fill. Instead, we have the, well, not the whole method, the button state parameter. And so we could say that if that button state, and we can test that against the button state enum which contains pressed and released. So we'll check the button state against pressed. So if it is pressed, then we draw the fill, otherwise we don't.
Okay. So
that's really where the logic is going with the button state. Now what we can do is when we make a call to this draw button, we can just pass into it a button state from the mouse state itself. So I think it's probably time for magic numbers now that we have to align something onto the screen. So let me make my first call to draw button. I'm going to put this before the cursor so that when
the cursor is always on top.
Exactly. So we'll push that one down. We'll make a call to draw button, and then we'll give a new vector 2 for the position, and then here come the magic numbers. I want the offsets to be 5 in X and then 30 in Y. 30 so that we move down out of the way of that text. And now the button state that I want to feed is from mouse state dot, let's start with the left button. So we'll feed the left button over to the button state parameter. And then the text label is going to be L button. And at this point, let me build, make sure that everything is working, and do a test, make sure that it's aligned properly and working. So we have left button. Probably need to work on the alignment. I must have
just take that top one and pull it up a little bit.
Let me jump out just for a moment.
Instead of 10, 10, 10, 5 maybe.
Since these were offset 5, let me do a 5 by 5 offset.
Yeah.
Maybe that would look better.
And much better.
And we can test now. If we hold the left button down, we see that the button gets shaded. So we can actually see that used to represent mouse button input.
Very cool.
Just like we had done in the keyboard lesson. And now that this method has been proven to work, it's very simple to make the second one. I can go in and simply copy the entire line, paste it in, and change the offset. I'll move it down about 25 pixels, so we'll get a final position of 55 in Y. Though I do want to pass to it the mouse state dot right button as the button state, and then we'll caption this R button. So now we have left button and right button as two separate inputs.
Very cool. And our own custom cursor and text at the top indicating exactly where the cursor is on the screen.
And really, that's all I had in mind for the mouse lesson. Again, just showing, one, how we work with the position of the mouse, the X and Y, even how we can package that up into a vector 2 for easier handling on the screen. Of course, just showing the values held within the position. And then taking a look at button input and reusing our old button function and adapting it to a button state so that we could plug in the actual values from the mouse state struct.
Okay. So with that, let's go ahead and close this out. Jump back over here real quick and come on back down here. And that takes care of the mouse app. And in the next one, we're going to put together the Xbox 360 controller application to demonstrate several of the buttons and some of the thumbsticks and the triggers on the controller. So with that, that's going to wrap up this lesson. Thanks a lot.